indicates that the set A is not a subset of set B. All right, so we just talked about that. To show that set A is not a subset of set B, one must find at least one element of set A that is not an element of set B. So over here, we said you could say 4 is not an element of set A, or you could say 5 is not an element of set B. That's why it's not a subset. Okay, so determining subsets. So here they give us an example. Determine whether set A is a subset of set B. What do you think? Is it a subset or not a subset?
I would still say it is.
And I think you are right, because you guys agree that all of these elements are inside of set B?
Okay, I understand, both of them have boat, both of them have train and plane, but automobile, why would you still say, I still says yes, because I did my reading, but I just couldn't understand why is it still a subset if B has automobile and A doesn't?
Oh, okay. Because subset just means it has to be.
Okay, I get it.
As long as all of these are in there, in here, then that means it is a subset. What about the other way around? Is B a subset of A?
No.
That would be no, because automobile is missing in set A. So that's why that would be a no. All right, very good.
Okay.
All right. Now there's another definition. This is called a proper subset. The only difference is that it doesn't have the little equal sign on the bottom. So for it to be a proper subset, it can't be equal. So that's the only difference. It still says the same thing, if and only if all the elements of set A are elements of the set B, but A cannot be equal to B. So that's the only difference. All right. So let's look at an example. Determine whether set A is a proper subset of B. So in other words, is A proper subset of B? Just think of it as less than, but not equal to. Are all these in here?
No. Oh, yeah, jazz, pop, and hip hop, but not rap.
Okay. Yeah, so we got jazz is in there, we got pop is in there, and we got hip hop is in there. So do you guys agree that A is a subset of B then? A proper subset? Because they're all in there. All of these are in set B. But the other way around, that would be a
no.
That would be a no. Yeah. Because classical is not in A, and that's it, right? Classical. Yeah. Okay. So that's that. Determine whether set A is a proper subset of B. Is A proper subset of B this time?
Yeah. I think it's equal.
Yeah, they're equal, right?
It's just equal. It's not proper because their letters are not in the same
order. No, it doesn't matter that they're not in the same order. As long as for it to be proper, it cannot be equal because it doesn't have the line underneath. So these are equal to each other, even though they're not in the right order. So it makes it not a proper, but is it a subset?
Yeah.
Yeah, so it is a subset, but it's not
proper.
A proper subset. Yeah, so it's just a little tiny difference. The only difference is that it cannot be equal, and this one is equal. So that's why it's not a proper, but it is a subset. All right. So let's keep going. Let's see what the next slide says. All right, so now we want to figure out the number of distinct subsets. So let's give you an example. Let's say you had a set of A, B, and C. Let's count all the, oh no, I got disconnected. Let me reconnect the screen. All right, so let's just say we had a set A, B, and C. How many distinct subsets are there? So let's start with the set of nothing. So you have this one, the empty set. Now let's write out the sets that only include one element. A, B, C. Now let's include the sets that have two elements.
A, B, A, C.
A, B,
AC.
A, C, and there's one more.
I like the place.
B, C.
Song, intro.
BC. Yeah, BC. And then the last one is the set that has all three. A,
A, B, C.
Yeah. So how many total?
1, 2, 3, 4, 5.
9, 8, sorry.
Yeah, I'm counting 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's how you figure it out. But the easier way is there's a formula, 2 to the nth power. So 2 to the nth power, where n is the number of elements. So n
8.
that is equal to the number of elements. So how many elements are there in the set, the original set?
3.
3. So that would be 2 to the third power, which is 8. So there's 8 subsets. So you can figure out how many subsets there are just by using the formula, or you can actually write them all out. The 2 subsets that you can always count on are the empty subset for sure, for all of them, and also the set itself. The original set is always a subset, and then the empty set. So those are the 2 that you can always count on. And then you have to figure out how many of the others there are. So what if there were 4? What if I included D? Anybody know how many subsets there would be now?
4.
Oh, that would be the number of elements. So how many subsets?
16.
Yeah, 2 to the 4th
Oh, okay.
power. That's going to be 2 times 2, 4 times, right?
Mm-hmm.
That is 16 subsets. So I'm not going to list them all out. That's going to take a while because you would have to write A, B, C, D, and then A, B, A, C, A, D, B, C, B, D, and then you'd have to write, oops, all the sets that only have 3 elements. So there's 16 total, but you could write them all out if you wanted to. All right, so that is how you figure out how many subsets there are. All right. What if they asked how many proper subsets? Which one would we have to get rid of from all of these? Which one is not proper?
Is it ABC?
Yeah, that's the one that, remember, if it's proper, it cannot be equal to. So we would remove that one. So the formula is 2n minus 1 because you're just getting rid of 1. So here it is, 2n minus 1. That's for distinct proper subsets.
2n minus 1.
So let's say you had 1, 2, 3, 4, 5. Anybody know how many
3, 4.
proper subsets there are?
Um,
31.
I think you're right. Let's see. It would be n is 5, right? Because there's 5 elements. So it'd be 2 to the 5th power minus 1. That's going to be 32. You're right. Minus 1 is 31 proper subsets. So you just have to be careful if they say proper or if they don't say proper. If they didn't say proper, what would the answer have been?
32.
32.
Yeah, it just would have been 2 to the 5th, which is 32. Very good. All right, so that's how you figure out the number of subsets or proper subsets. All right, here's another example. Determine the number of distinct subsets. So notice that they don't say proper this time. They just say subsets for this set, SLED. So, anybody know what that would be?
16.
Yeah, good. So that is n equals 4. So 2 to the 4th power. We don't subtract 1 this time because it doesn't say proper. So that is 16 subsets. All right. Part B, they want you to list all the distinct subsets. So this time they want us to write them all out. So remember, you can always start off with the empty set and then write out the ones that just have one single element in it. So what would that be?
SLED.
SLED, no,
L,
SLED.
E, D. All right, then the ones that have two elements.
SL, SE, SD.
SD.
All right, there's a couple more that have two.
LE, LD.
Yeah, very good. LE, LD.
I don't know if a real
And
scout guy
ED.
can still get whatever milk.
And then the last one would be that one, right?
ED.
Yeah, ED.
Yeah, good. E, D. Now we have to move on to the ones that have three elements.
Yeah.
SLE,
Sugar or
SLD.
lasts for a long.
S, L, E, S, L, D.
LD.
And I think there might be one more with 3.
LED.
Never gonna see him again.
LED, right? LED. All right, very good. LED. And then the last one would be all of them, right?
All of them.
All right, so let's count them. We know there should be 16, so let's see if we got them all. 1, 2, 3, 4, 5, 6.
We're missing one.
12, 13, 14, 15. You're right. We're missing one. I think we're missing. I don't know. I think we're missing one that has 3 elements in it.
Elements.
So we have SLE,
SLE,
SLD,
SLD.
LED. I think there's one more that we missed.
We have ED. Yeah, we have that.
SED.
SED. So I'm just going to squeeze it in here. SED. All right. So we got them all. 16 now. All right. Hopefully they don't ask us to list out one that has 5 of them, because that would be 32, and that would be way too many. Okay. Oh, and we're done. That was quicker than I thought. Okay, so this one was a little bit short. The next one's a little bit longer. Let's just take a quick look at one homework problem before we move on to the next section. So let me share my screen so we can look at just a homework problem before we move on. All right, so share screen. All right, we are in week 2, 2.2 homework. So here's 2.2 homework. Oh, okay. Oh, obviously we have to look at the book. I forgot about that. Yeah, I think I have the picture real quick. Let me see if I can look up the picture real fast of the book. Does anybody have? This looks like 2.1, isn't it? This looks like the stuff that we learned last time. Let me double check. Look at number 59. So look at 59. It says for the set D, D equals ABC. Is A an element of set D? Would you say yes or no?
Yeah.
Yeah. A is an element of set D. Very good. All right. Is C a subset of set D?
Yes.
It's kind of a trick question.
Good question.
What do you think? Is that a yes or a no?
I would say,
Yes.
You would think it is a subset, right? But it's missing the brackets. See how if it doesn't have brackets,
Yeah.
it's not a set. So
Not a set.
it's not a set, it's an element. So you're not supposed to say it's an element, a subset. It's an element of D, not a subset, because it's missing the brackets. If we would have put brackets around it, then it would be a subset. So this one's a trick question. It's supposed to be no. All right, and then part C, see how this one does have the brackets?
Mm-hmm.
So is A comma B a subset of D?
Yes.
This one is, because it does have the brackets. So this one's so it's no, no, yes. So if it doesn't have brackets, it can't be a subset. It has to be just an element. So just be careful with that. All right. Let's see. Is there
A
another
was
one?
no. You said A was no or yes?
Oh, sorry. A was yes. Sorry. So it's yes, no, yes. Yes, no, yes.
Okay.
All right. Oh, let's look at number 40. A set contains 9 elements. How many subsets does it have? And then how many proper subsets does it have? So see if you guys can figure that one out. If you need to use a calculator, feel free to use a calculator. So do you guys remember the formula for how many subsets there are?
The 2n, let me see.
Yeah, 2 to the nth power, right?
Yes.
So 2 to the n, 2 to the 9th power is,
512.
yeah, it's going to be 512. So 512 is the number of subsets. What about how many proper subsets?
511.
511. All you have to do is subtract 1. Very good. So yeah, the answer for part A was 512, and for part B, 511. Okay, that's pretty much it for this. Let's go ahead and start the next section. This one's a little bit longer, so we'll just do we'll do a little bit of it, and then we'll take a break, and then we'll come back and try to finish it. I'm not using the PowerPoint this time. I'm using a different page of notes that I found somewhere that I thought was really good. So we're going to switch it up a little bit, not do PowerPoint for every single section. All right, so this one says Venn diagrams and set operations. So in this section, we will learn a useful technique for illustrating set relationships called Venn diagrams. Has anyone heard of a Venn diagram?
I forgot.
It's just like
Yeah.
it's like when you have a rectangle and then you have circles, and the circles represent the sets. So you'll see a rectangle usually represents it's called the universal set. So this is a universal set. A universal set is a set that contains all the elements for any discussion. So if we're talking about cities in California, or let's just say states in the United States, this would be all 50 states in the US. All right, and then maybe you have West Coast states, maybe you have East Coast states. Maybe that's how you're dividing them up. So that's just an example. All right, consider U. So U is everything. U is a universal set. So this is all the elements in the rectangle. Case 1. So you have A and B. So we have to draw that. So let's draw the 2 sets. Here's A. Here's B. You should label them A and B. So in set A, we have 1, 2, 3, and in set B, we have 4, 5. Is there any overlap between these two?
No.
No. So that means you should write the 1 and the 2 and the 3 over here, not in here, because that means that it's also part of B. And then 4 and 5 should be over here, and there is nothing overlapping. All right, so that's how you would write it. All right. Actually, you could have drawn the picture like this instead, because there's no overlap. If there's no overlap, you don't have to. That's a bad circle. If there's no overlap, they don't have to touch, since there's no overlap. So that's called disjoint sets, because there's no overlap. All right, case 2. Do you guys see overlap here?
Yes.
So yeah, for sure. So now we have to draw the circles so that they overlap.
Oh, yeah.
You'll put 3 in circle A,
Okay.
and then you'll put the 1 and the 2 in the overlapping space.
Yeah. All right, very good. And that is it. So as you can see, B.
Explain that again?
Yeah, set B has 1 and 2 in it. So as you can see,
Oh, okay.
it's got the 1 and the 2. And set A has 1, 2, and 3, but only the 1 and the 2 are shared with both
Oh,
sets.
okay.
So it has to be in the overlap region. So that's called overlapping sets, you could call them. Overlapping sets. And then the final set, notice is that they're equal, right? So you could just draw one circle and call it A and B. And 1, 2, 3. I'll just call those equal sets. And then the final case is there any overlap?
I would say, yeah.
Yeah, they have one element of
3.
the 3. So A, B. So where should I put the 3?
I think in the middle.
In the middle. And then the 1 and the 2 anywhere over here, right? And
Yeah.
then the 4 and the 5 would be anywhere in B, as long as it's not in the overlap region. All right.
And what's that one called? Case 4?
Oh, sorry. This one's called intersecting sets. So this one, see how I think I messed up on the overlapping one. So the overlapping one should have been, let's draw this one. See how B is contained in A? So B is contained inside of it.
Oh.
Because the 1 and the 2 are in here, and then the 3 is over here. So the entire set B is inside of A. So
Okay.
I'm trying to remember how to word that. I think they worded contained sets. Let's just write contained sets, because it's contained inside of it. The entire set is contained inside of the other one.
Okay. Okay.
All right. So those are the 4 different cases. You'll either have 2 sets that don't intersect, so that's called disjoint. You'll have a set that's contained inside of another set, that's called contained sets, and then 2 sets that are equal. And then you have just intersecting sets. All right. So let's look at what else they have for us. Complement. So here's another definition. The complement of a set is denoted by this little apostrophe, A apostrophe. That means complement. And it's a set of all elements in the universal set that are not in set A. So let's look at an example. So they give you the set A, and then they give you the universal set. So let's draw set A. So it's got A, C, and D. And in the universal set, which would be in the rectangle, it's A, B, C, D, E, F, G, H. So A is already here. So B, we have to write B anywhere in the rectangle. C is already here. D is already there. So now we just have to write the rest of them. E, F, G, H, right? Do I have them all?
Yeah.
I think I do, yeah. A, B, C, D, E, F, G, H. Yeah. All right, so that's how you would represent the set A inside of the universal set. But how do we find a complement? Remember, it says it's a set of all elements in the universal set that are not in set A. So does anybody know what would be included in the complement? Everything in the universal set that's not in A.
So what would be B, E, F, G, and H? Yeah,
Yeah, exactly right. It's everything that's outside of A.
outside
So
of it.
outside of A would be B, E, F, G, and H. So that's how you find complements. It's everything outside of the set A. All right, here's the word intersection. And that means there's overlap, the overlap. And so this is a symbol that they use for overlap or intersection. It's like an upside down U. So let's do an example. So first let's draw the sets. So you have set A, set B. Anybody know what should go in the middle?
3, 2,
Let's see.
3 and 2.
I'm just seeing 3. Oh,
Oh,
and one more.
3.
I should have- Yeah, 3 and 8 too. So you're right, 3 and 8. And then what should I put in this region?
1
1 and 2.
and 2. 1 and
Yeah,
2.
just 1 and 2. And then what should I put in this region?
1, 6,
1,
7.
6, 7.
1, 6, 7. 1. Oh wait, I think we missed one. Actually, did anybody see a mistake?
1.
Yeah, we missed that one. So it should have been 1, 3,
3
and
and 8.
8. And then in this region,
2.
just the 2, right?
2.
And in this region,
6 and 7.
6 and 7. All right, so now we got it. And then what goes in the universal set outside of these circles? What are we missing?
4, 5, 9, 10.
9 and 10.
9, 10,
4.
4.
I think it's one more, is it?
5.
Should be one more.
3, 9.
4, 5, and 10.
Oh, got 7. 3, 2.
Looks like it's just
Oh,
5.
5.
Yeah, 5. Yeah, 5. So now we got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we got them all. All right, so that's the first part. Now we can find the intersection. Anybody know what the intersection would be?
I'm just gonna take a guess. 1, 3, 8.
Yeah, very good guess. Yep, 1, 3, 8. That's the intersection. So 1, 3, 8. All right, now they want the intersection, but they want the intersection of the complement. See the little apostrophe? So first, let's find out what's inside of the complement. Anybody remember how to find the complement? It's everything outside of the circle A.
4, 5, and 9, 10.
Yeah, and also 6 and 7 too.
7.
So-
Okay.
Yeah, so it's everything outside of A. So that's going to be 4, 5, 6, 7, 9, 10. And then they want the intersection with B. Well, B is 1, 3, 6, 7, 8. All right, so here's B, 1, 3, 6, 7, 8. So what's the intersection between these two sets? In other words, what do they have in common?
6 and 7.
A,
That's
let's
a-
see, 6, 6, 7, 7. I think that's it, right?
Yes.
Yeah.
Yeah, that's it. So yeah, you're right. So the answer would be the set containing 6 and 7. All right, so first thing we had to do is find a complement. That was this set, everything outside of set A. Then we had to find set B, which is just given to us over here. And then you just find the intersection of those two sets. That means what they have in common. All right, this one, notice that the complement is outside of the parentheses. So first, it's like order of operations. So first you do the parentheses first. So let's do the parentheses first. We already did it though, right? 1, 3, 8. So now we have to find 1, 3, 8, the complement of that. The complement of 1, 3, 8 is everything outside of 1, 3, 8. What's everything outside of that?
2, 4, 5, 6, 7, 9, 10.
Yeah, exactly right. So everything except 1, 3, and 8. So that would be 4, 5. Oh wait, we've got 2, right? 2. It doesn't have to be in any order. It can be in any order, but 2, 4, 5, 6, 7, 9, 10. So in other words, it's just everything that's outside of 1, 3, and 8. So 2, 4, 5, 6, 7, 9, and 10. All right, so that's how you find complements. All right, moving on. Let's do one more. Let's do one more example. Actually, let's just do up to this, and then we'll take our break, and then we'll come back and finish it off. All right, so a new definition is called the union, and the symbol is a U. That means union. So a union is the set that contains all the elements that are in A or in B. Basically, you're just combining the two together. So let's draw the picture again. A, B. Well, we start with the overlap. What was 1 and 6, right?
Yes.
All right, so 1 and 6. And then over here, what numbers go here?
2, 4,
2 and 4
2 and 4. And then over here would be
3, 7, 9.
and 9.
3, 3, 7, 9. And then in the universal set,
Go down there
5,
with the button and dance with her.
8,
You should have waited.
10.
9, 10.
and 9. Oh no, 9 is already
No,
there.
9 is in B.
9, no.
Yeah,
Is it
9 is B. So let's just make sure we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I think we got them all. All right, great. So see how it says U? That means union. That means everything in A and everything in B combined. So everything in both of these sets combined. So you just put them all together into one big set. So if you
1,
do that,
2, 3, 4, 6, 7, 9.
you got it. That is right. So we just combined everything in A and everything in B together. So that's what union means. Think of union as two people getting married. When two people get married, all their stuff goes into one big group. All right. Let's just do one more before we take our break, and then we'll take our break. So first thing we have to do is find the complement of A first. So what is an A complement? Anybody know? Everything outside of this circle?
3, 5, 7, 8, 9, 10.
Yeah, very good. Everything outside the circle would be 3, 5, 7, 8, 9, and 10. So it's always a good idea to circle A and then only get the stuff that's outside of the circle. So that would be all the stuff that's remaining. All right, and then we have to do a union with B. And B, we already know B is, it's up here. 1, 3, 6, 7, 9. And then remember union, that means you're just combining these two sets together into one big set. But you don't want to repeat, you're never supposed to repeat elements. So does anybody know what would go in there?
1, 3, 5, 6, 7, 8, 9, 10.
Yeah, and notice you didn't repeat the 3s, even though there's 2 3s, you don't write it twice, you only write it once. So we got the 1, we got the 3, 5, 6, 7, 8, 9, 10. And we don't repeat 7, 9, or 3. So there you go. That is the final answer. Very good. So this is going to be very similar, but this time you're going to find the B complement first, and then do the union with set A. So we'll do that when we get back. So let's take it's very similar to that one. Let's just jump to one of these. Let's do this one or that one. Let's just do F. Right, so first we have to find the intersection of A and B, and then we take the complement after. So first, let's find A intersect B, which I think we already did. Oh, we didn't. Okay. You can just look at the picture and see what the intersection of A and B is.
1 and 6.
1 and 6, yeah, so that's going to be 1 and 6. But then they want the complement of that. So the complement would be that. So now we have to figure out what's everything outside of 1 and 6. So what's everything outside of 1 and 6?
5, 8, 10, 2, 4, 3, 7, and 9.
Yeah, you got it right. So that's everything outside of 1 and 6 would be the rest of these. Right, so it doesn't have to be in any specific order. So it's just going to be, see if I can write this out. It's going to be 2, 4, 5, 8, 10, 3, 7, and 9. So everything except 1 and 6. All right, so that's how you would do the complement of the intersection. So this one is going to be similar to that one, but instead you're going to find the union first and then the complement. So let's just skip over because we still have a couple pages to go. All right, so this one says, use the Venn diagram to determine the following sets. That's weird. They don't have anything there. I think this is a mistake. They're supposed to have something here. So I can just make something up real fast. Let's call this, I'll call this A, B, C, D, E, F, and G. All right. So anybody know what's in the universal set?
C.
Not quite. The universal set is everything.
Oh, yeah, that's right. A, G.
So A through G.
A through G. Yeah, I'm sorry.
A, B, C, D, E, whoops, E, F, G. That's everything. All right.
Okay.
What's in just set A?
B and C.
B, C.
Yeah, B and C. Very good. So that would be B and C. All right. What's in the complement of B? So don't careful with the apostrophe. That's the complement of B would be
A, B, G, and E.
yeah, everything outside of the circle B. Very good. A, B, G, and E. So A, B, G, and E. All right, now we have to find the complement of A first, and then we can do the union with the B. So what's the complement of A going to be?
A, D, F, E, G.
A, D, F, G. Yeah, A, D, F, G, and E. Union with B. What's in B?
CDF.
CDF. And remember what the union means. Union means combining the two sets into one big set.
A, C, D, F, G, E.
Yeah, I think you're right. So we got A, we got C, we got D, got F, G, and E. And we don't repeat the D and the F again. We only write it one time. So that is correct.
Can you explain that one again, the union?
Yeah, so first thing we had to do was we had to find A complement. That would be this set right here, right? That's A complement. Everything outside of A. And we found it to be A, G, D, F, E. A, G, D, F, E. And then we have to do the union with B. So here's B, C, D, F.
CDF, okay.
C, D, F is B.
Uh-huh.
And then we have to take the union of these two sets. That means you just bring them all together into one big set without repeats. So we just combined this one with this one, and we took out the double. So no more, F only one time, D only one time, and we added the C. So A, C, D, F, G, E, yeah.
Okay.
Okay. So over here, it's going to be the same thing, but this time it's a complement of B. So let's see, what's in A first? A would be, whoops,
BC.
B, C. So B and C. Union, what's in the B complement? So everything outside of B would be?
A, B, E, G.
A, B, E, G. A, B, G, E. And then the union means you're combining them, right?
Right.
So what would be in the final set?
A, B, C, E, G.
A, B, C, G, and E. Yeah, we just merged those sets into one and then take out the duplicates. All right, very good. So that is it. And this one's a little bit different because it has the parentheses around it. So first you're supposed to find the union of A and B. So first let's find the union of A and B. That just means everything in here combined with everything in here. So what would that be?
B, C, D, F.
B, C, D, F. Yeah, B, C. But then we have to take the complement of that. That means everything outside of that. So everything outside of this.
A, E, G.
G.
A, E, G. Very good. Yeah, A, E, G would be our final answer. Oops, A, E, G. And remember, the order doesn't matter. You can put them in any order you want. And that's the final answer. Oh no, it's frozen. All right, looks like it froze, but let's see. Okay, yeah, so disconnected. Let me connect again. All right, last one. So now we have to find both the complements first, and then we take the intersection after. So let's find A complement first. Everything outside of A would be? A, D, E, F, G, right? A, D, E, F, G. So A, D, whoops. A, D, F, what was it again? A, D, F, E, G. All right, so that's A complement. Now we have to find B complement. So everything outside of B would be A, B, E, G. All right, now between those two sets, anybody see the intersection, which means overlap? What do they have in common?
A.
A, anything else?
The E,
and the,
G.
yeah, so your final answer would be A, E, and G in common, right? A, E, and G. I don't think, yeah, that's it. That's the final answer. That's what intersection means. Intersection means the overlap or what they have in common. Okay, so that does it for that page. All right, we have one final page to go and then we're done. So let's look at this final page. It says, given the following, determine the set C intersect B union A. All right. So that's probably, it's probably easier to draw a Venn diagram. So let's just draw a Venn diagram first. All right, so that's a universal set. And then we have A, B, and C. So let's see if there's any, let's see, A is going to be odd and it's less than 10. What are the odd numbers that are less than 10?
1, 3, 5, 7, and 9.
Yeah, and then set B is the even numbers less than 10.
2, 4, 6, 8.
Yeah, so these two aren't going to have anything in common, right?
No.
So actually, I should draw the picture a little differently. Are these two going to have anything in common? A and C?
Let me see.
A.
I don't know.
Looks like they will. And then E and then B and C will also have some numbers in common. So let's draw the picture more like this. All right, so this one is B. All right, so let's see what A and what is A and wait, what does A and C have in common? A is 1,
3, 5.
3, 5, 7, 9. And this one says all the numbers that are less than 6. That's
1,
gonna be
3, 5.
1, 3, and 5.
Yeah, 1, 3, and 5. And then in set A, it's gonna have 7 and 9, right? Those are
Yes.
the odd numbers. And then C is gonna have 1, 2, 3, 4, 5, 6. So we're
2.
just missing the
and
4 and
2 and a 4 and a
4.
6. Well, 2 and 4.
1,
2
4.
and 4, but that's also going to be overlapping B, right? Because B is the evens.
Mm-hmm.
So it's going to be 2,
2 and 4 in a little space.
4. And then we still have, that's it, right? And then we have 6, 8.
8. And that's it.
I think that's it. 1, 2, 3, 4, 5. Yeah, that's it. All right, we got it. Oh, and then in the universal set, we have 9. Oh, no, just 10, right?
Yeah, just 10 looks like.
Oh, no, it's less than 10. So never mind.
So nothing.
Nothing. Nothing. Okay, so now we have to do this. So let's start with the parentheses part. What's the overlap between C and B?
What's the overlap?
2 and 4.
2 and 4.
Yeah, that's the overlap. So that's going to be 2, comma 4. That's a bad 2. Okay, 2, comma 4. And then we have to do the union with A. A is 1, 3.
1, 3, 5, 7, 9.
9.
All right, very good. So now the union, that means union means combine all of these together, right?
So it's 1, 2, 3, 4, 5, 7, 9.
Yeah, I ran out of room. Yeah, so that is your final answer. It's 1, 2, 3, 4, 5, 7, 9. We just combine these two sets together And that's your final answer. So that's how you do this. You always have to do the parentheses parts first, and then you have to do the union with set A, and that means combine these together. All right, I think the hard part was probably drawing the picture. And then once you have the picture, hopefully it's not as bad to do the second part. All right, let's look at this one. It looks like it didn't print out that good, but this should be a union.
And an overlap.
intersection. Yeah, and an overlap. Okay, so. All right, there we go. So first let's draw the picture again. Okay, so we got the U. Let's see, is there are A and B and C, do they all overlap, or looks like,
Yes, they all overlap.
yeah. What
And they
about,
all got H in it too.
H.
okay, yeah, so that means all three are gonna overlap, so. That didn't come out right, okay. All right, so we got A, B, C. Let's do the three overlapping numbers first.
So C and H.
H. It's in the middle.
All right, so
Okay.
C and H. All right, now let's just focus on A and B. What's A and B have in common? Anything else?
No, just that.
Yeah, that was it. Okay. What about A and C? Do they have anything else in common?
Yes, A and C have F in common.
F, right?
And G.
And G. All right, so F and G should go here.
In the little open space.
Yeah, because that's the overlap between A and C. Okay. Now let's see if A and B have any. Oh no, we already looked at A and B. How about B and C?
B and C have A that overlap.
A.
And that's it.
Yeah, just A. So the A would go here.
So
Disconnect.
your writing is frozen.
Yeah, I think it's frozen.
Yeah, okay. So let me try. C was just A, right? I'm sorry, B and C. It just had the A in common, so I put it right there. All right, now we have to fill out the rest of the stuff. So what's going to go in A?
F.
We already have the
F,
F. The F and the G are here, so it's
Oh,
just going to be
there.
B,
B.
B and J, right?
Mm-hmm.
The B and the J. All right, what's going to go in just B?
Look like E and I.
E and I. And then the final one, C, it's going to have A is already there, C is already there, F is already there, G is already there, H is already there. So C is already complete.
Yeah.
And then in the universal set, anything go in the universal set? A is done, B is there, C is there.
I think K.
Disconnect it again. All right, so it should be D, but the screen is not connected. So let me universal set. I see D is missing. So D needs to go here. What about E is there? F is there? G is there? H, I, J. And K. K is missing. So we just have two in a universal set. All right, now we can do this problem. First, we do parentheses. B intersects C. Anybody see what's in B intersects C?
B.
C, H, and A.
A.
C, H, and A. But then it's a complement of that, right? So everything outside of that.
B, F, B, J, F, G, E, I.
Yeah, everything else. So let's write that out. So that's going to be D, K, B, J, F, G, E, I, right? Everything except this.
Yes.
All right, now we have to do that with the union of A. A is
B, J, F, G. I can't see the other letter because you got it crossed out still.
Okay. I'm just gonna copy this right here. That's A right there. Oh, I think it's frozen again.
B, C, F, G, H, J.
Yeah, exactly. All right, then we have to do the union of those two sets, right? It goes. You guys see it now?
Yeah.
All right, so now the union, that means we just combine it into one big set. So looks like it's gonna be everything except what's missing. Looks like A is missing. I think that's it. K. Oh yeah, K's there. So it's everything but A, huh? Yeah, it's everything except A. That's the only thing that's missing from the set. So everything except A. All right, the last one. So let's do the parentheses first. Let me just fix this. Union, intersection, union. So parentheses A union B. Everything in A and B would be everything there. So A, B, C. All right, let me write that out. B, J, F, G, C, H, E, I, A.
Yes.
All right, and then let's do A union C. That's going to be everything in A and C.
B, J, F, G, C, H, A.
Yeah, you got it. Sounds good. So B, J, F, G, C, H, A. Now we have to find the intersection. That means what's common, right?
F, G, C, H, A.
I see a B, I see an F and a G, a C, an H, an A, a J. That's it, right?
B, J, F, G, C, H, A.
All right, B, J, F, G, C, H, A. All right. So you just have to be kind of careful when you're doing this because you can make a little mistake and that will throw everything off. But that's it. We got through it. Oh, there was one more, but that's okay. We'll get to that next class because we're obviously out of time. But you should be able to do the quiz and everything else now. So here is the one last time.